So now let's have a look at some design considerations, some things to keep in mind as best practices and just good ideas when you're looking at implementing and advising your customer as they get ready to delve in to the adoption of virtual SAN. So I think this first one really goes without saying. Check the hardware compatibility list. Granted, if you're using ready nodes, you're not going to have to sweat this. It's going to be a moot point. But we all know that not every OEM ready node is exactly what we want for that infrastructure. And sometimes we're put in a position where we need to, for lack of better words, roll our own. And so if we're having to do that, make sure you're checking everything from the solid state disks, the spinning disks, the HBAs, drivers, firmware, vSphere additions, all of that. That way you can ensure the greatest level of success moving into that project. So let's take a look at how you design and how you give best guidance when you're implementing a virtual SAN infrastructure. So over here, we're looking at this idea of designing for the life cycle. Now, designing for the life cycle means that you're not just looking at today, you're also looking at tomorrow. And you're able to start wrapping the customer around the use case. Get them to understand that it's not just about what they have today, but where they're going in the immediate future. Now, if you need assistance having that use case conversation, then definitely reach out to your VMware systems engineers, solution architects, so that they can help you with that conversation. Because although you might be able to start with the standard 3-node minimum for VSAN, that might not be where the customer needs to be on a go-forward basis. They might need to grow substantially larger than that in order to ensure that they're covering things like maintenance windows, proposed downtime, may have merger or an acquisition that they're dealing with, significant onboarding, or maybe several new projects, again, inside of a use case that could really drive this adoption in one direction or the other. So to underline, make sure you're designing for the life cycle. There are a couple ways to design for the life cycle. One option is to scale up. Now, again, we know that we need to start with at least one solid state disk and one spinning disk to create our disk group, and we can multiply that up to 5 times inside of each host, giving us some really significant storage. But let's say we start with that 3, and the idea is simply that all we're going to do is just scale up. Now, this is relatively easy to do, but it's not necessarily the most consequence-free and not necessarily the most beneficial when you're looking at the cluster and the infrastructure as a whole. After all, scaling up flash can be difficult, and it is going to become expensive. So as that workload continues to grow, you're going to need to be talking about higher density flash storage. And then what are you doing with the old flash? Are you deprecating it? Are you going to have lost data? How are you going to get that recaptured? And also, you're going to be bringing hosts offline during this process so that you can drop in the new equipment. You have to make sure that that's designed for as well. It might not always just be one host at a time, depending on scale. So this is going to really impact the decisions that you're making when you're looking at the customer's maintenance windows, proposed workloads and use cases, and how that is going to interact with scale up. On the other hand, we have scale out. Scale out's relatively straightforward because all we're doing is adding additional nodes inside of the cluster. And now with vSphere 6, we can go up to 64. So we certainly don't have a shortage of nodes that we can add in. Additionally, the scale out approach just like in compute, is going to benefit us when we're talking about the cluster as a whole. It's going to impact evacuation rates for things like vMotion, high availability. It's going to help streamline distributed resource scheduling because we're going to have less hosts to deal with. And then VSAN is going to be able to benefit from it because we're going to have more hosts that we can bake in to maintenance, high availability, and redundancy within the virtual SAN array. So depending upon the way your customer is going to go, depending upon the way they're going to grow, we decide whether or not it's best for them to scale up or to scale out. And these are the decisions, the conversations that you as a trusted advisor need to have inside of your customer's boardroom so that you're giving them the right advisement, the right time. So it's always very common just to start up and say, hey, you want to buy VSAN? Let's just start off with a 3-node cluster. That's the easy way to go, right? Well, it might be the easiest, but it might not always be the best. After all, what would happen if you started with that 3-node cluster and then your customer had to take down a host for maintenance, or maybe there really was a disaster that occurred? Now you only have 2 hosts left. You might have been better off looking at a 4-node VSAN cluster to give them the base minimum plus 1 so they can take that host offline, and then they've already got a second host ready to go to replace the offline host and come back to the trinity they need for redundancy inside of their virtual SAN infrastructure. It's the same ideas we've applied for years inside of compute. How many do you need? Is it n plus 1, n plus 2, etc.? We need to come back to those ideologies when we're looking at VSAN the same way we use them with vSphere. So keep in mind, it might not always be best to start off with 3. Look at the value that you may have with starting off with a 4-node VSAN cluster for those smallest customers. Another thing to consider are the number of disk groups per host. Let's take a look here. So why would multiple disk groups be better than just one? Well, you're definitely reducing the failure footprint, right? It's becoming reduced because you're spreading the possibility of failure across a wider area. You also have less components to rebuild. And if you have less things to rebuild, you're going to be able to do it much faster. And if you're adding more disk groups, again, you can add up to 5 in any individual host, you're also going to improve performance because you're adding additional read cache and write buffer into that storage node. This means that when things do have to change, that not only are you recoverable, you can do it fast, and you're going to be speedier in between failures.